All right, I gotta start over again here. So class, we do have an exam coming up here. We want to take this time to go over any homework questions you guys have. That's the thing here. I even read my book, so this is great. So let's do this here. First of all, let's do any list of any homework questions per se, and if we have extra time, we'll do some other stuff here. Let me do this real quickly here. 2.1. No. Let me do it this way then. We'll get it one way or another. Okay, so 2.1, 2.2, 2.3, 2.4, and 2.5. How about that? Well, Georgia.
Okay, I have one for 2.4.
Uh-huh. Just give me, yeah.
17.
29. Yep, we're going to start a little list here as we go. Awesome. Yeah.
Question on 53 and 2.3.
53.
And 9 and 33 and 2.5.
9,
Yeah.
33. How about this? Give me section first, because I know which category it's under, and then give me the numbers here. Amanda, did you have one?
Yeah, Corinna.
Got it, okay. Hayden?
I put 21 through 25 and section
2.1. 21. Is it 21, 23, 25 then? Okay. Yep. All right. Cool. All right. Any others? Going once, going twice.
Oh, also 17 and 2.3.
2.3, 17. Okay. Boom.
I was confused on, then 2.3 is 61.
61. Okay.
Was
Evidence
used on 47.
2.3, 47. Okay. Let's jam. Hopefully we can make it through all these here. Okay.
2.3.
It seems to be that way.
2.2 took me like 5 minutes. And then 2.3 is so long.
Yeah. Yeah.
Okay, I'm going to refer back to this list each time here. So let's go with it. And you remind me as we go through it. So 2.1, I'm going to go try to make this quick. You guys tell me if I'm going too fast. We good? That's what you guys do. 21. 2.1, 21 says use a cofunction theorem. Very important. Cofunction theorem is the fact that, in fact, we've named our trig functions this way. Sine, when it was first invented, it was some funny names. They went through this whole entire translation process, and sometime along the way during the process, it got renamed wrong. So then it's kind of funny. But eventually, we're like, okay, so sine is like that, and then you have cosine, right? And we have secant, and we have cosecant. So each of these guys have these little co in front of them, tangent and cotangent. What does it mean? It means the same thing as complementary. We're good? So sine of 10 degrees is going to be the same thing as, wrote it backwards here. It'd be cosine of 80 degrees. And if you're punching into your calculator, and you put in sine 10 degrees, click enter. Cosine 80 degrees, click enter. You're going to get the same exact answer on it. 23, same thing here. You guys help me out with this one here. Tangent 8 degrees is cotangent of, you guys seriously do have to help me out. 82. Okay, and 25 to finish it off. Of course, got to do the abstract thing. So sine of x would be the same thing as cosine of 90 minus x. Yeah. There's a little theorem for the abstract. Okay, we're good there. And you guys, the ones that actually ask the homework questions, just tell me if you agree, now you get it, if everything's good. Okay, that was easy. 3 down. 17 and 47. Jumping to 2.3. 17, 47. One of those. Let's do 17 first.
We already did 47.
We might have.
Might
It
have,
was,
okay.
it was similar to one of the problems that we did, I just don't remember.
Gotcha, okay.
I think we did go.
Was it helpful to allow you guys to finish up homework for the whole entire chapter? So let's just kind of slowly work your way through it, or no? Or you'd rather like turn in the homework the next day?
I'd rather turn in the homework the next day and feel like I'm slack off doing it. I have a whole lot of time.
Okay,
I
gotcha.
get caught up in other homework, and if I have an actual beat that's in one.
Interesting, okay. I'll see. I'm a little second on that, okay. All right, right triangle. She'll think about it here. To solve the missing parts of the information, here it is. 17 is what, A? I'll label this triangle ABC. Normally, C is your 90-degree angle. The A and the B sometimes get switched, but mostly it's just clockwise when you write them. All right, let's go with it here. 32.6 degrees, and A is 43.4. Walk me through it, anybody? First thing to solve, easiest thing to solve. The other angle, yeah. These A and B have to be, whoa, that's thick. A and B would have to be complementary angles. Therefore, too thin. 2 1/4. Let's see how 2 1/4 looks like. Yes, that's better. Okay. All right. I feel like I'm doing a lot of work today. So angle B is 57.4. You guys check me. Is that right? Cool. Done there. All right. Talk to me. Anybody else?
I did sine of A, which is 43.
Yeah, 43.4.
Yeah, 43.4 over.
So a little C. And then I'm going to change it up just a little bit here. So actually, let me give you the formula first. So this would be little a over little c. Let me put in the angle measurements, 32.6, 43.3, 32.6, sorry.
Okay, so then the answer would be 8.4?
I don't know. I'm going to get there in just a second here. Let's multiply both sides by c. Now this one, if you guys have noticed, the trig functions, you got it one of 3 types, right? You either looking for the angle, you're looking for the top value or the bottom value. And each one of those just have their own little algebra stuff to do. So with this one, because the variable on the bottom, multiply through by c. So multiply through by bottom number. And then you have to divide out the trig function because you already know the value there. So divide out by sine of 32.6. And anybody with the c value? I mean, I think you told me what it was.
No, I was thinking something else.
Okay. Anybody with the c value? Little c. Haley? 80.6. I'm going to go with it unless someone tells me otherwise or I don't get a second. Second? Yeah, and let's see. Let's go back a little bit here. You guys remember the 30, 60, 90 triangle? You guys remember that one? So do you guys remember how this one was, let's see, this is 1. The side opposite my 30 is 1/2. The side opposite my 60 is 3/2. We learned that one, right? So I'm thinking if this is 32.6, and that's 43, I'm thinking this one has to be somewhere in the 80s. We good? That just kind of makes sense. All right, boom. And the next one. So I have little c, I just need little b. Kind of like little John, but different. Oh, yes, perfect. Okay, so we can go Pythagorean theorem. And that is A-okay to do because you know 2 sides of a right triangle, you can figure out the third side. Normally, what we want to do is we want to stick with the stuff that we were given initially, unless we know it to be an exact value. We good? That's kind of like the little nuance sort of thing here. So you could use the 57.4 degrees for your angle if you wanted to, because that's an exact value. 80.6, not exact value, because we had a round a little bit here, so you kind of don't really want to use that one. We good? Okay, B. Uh-huh. I'm going to use it of A here. Tangent of A is opposite, which is little a over little b, opposite over adjacent. All right, and the same thing applies here. So tangent of 32.6 is equal to 43.3 over b. And notice, again, it's the variable in the bottom. And so let's do this faster here. Can we multiply both sides by b? At the same time, divide by tangent 32.6 at the same time here. And a tangent 32.6 here. And out of curiosity, show of hands, how many did it that way? How many did it kind of like a quick one step? Multiply, you divide, you know what you're going to do, and you're done. 1, 2, 3. How many had to do 2 steps? I do it that way, I know that, and then I do it that way. Okay. Perfect. Any which way is cool. Okay, B is equal to 43.4 over tangent 32.6. Anybody? 7.9 agreed. Second. Cool. All right. I just want to make sure I get through all of those here. Okay, tell me if I'm going too fast, all right? Because I see a few people writing it down and a few people like, I am waiting for my homework problem to be given. So, that's what it is. Okay, I like that one. Therefore, I like that one. Cool. All right. 2.3. I think it's 47. Is that right? Okay. So we have this guy. Pretend it's a right triangle here. A, B, C, and D. A is 43 degrees. Angle B, DC is 57 degrees. Y is 11. Find X. Have fun. So right triangle here. This is nice. And so kind of think about it. Think about it. You kind of have 2 different right triangles here. You got the long triangle. You got this one here. You got the long one, which is A, B, C. And then you got the short one, which is D, B, C. So as you work through kind of each of these pieces, that's what you want to get through. All right, 11. Just checking here. All right. A little bit of a difficult one here. Was 43 a lot easier? You guys asked me. Yeah, 43 a whole bunch easier, a lot easier, because you're given a few little things here, then you can figure out the other stuff. All right, this one, we're going to have to create 2 different. Notice we can't do it directly here because
That's what I thought, but I couldn't figure out how to set them up.
So I'm thinking, let's see, if I'm going to use tangent. Notice if I use tangent, this little side right here, I'm going to call it just H. We're good? H is for the height. And so what I've done, I've made something that I could equate both of them to. And that's a little trick part here. So if I'm thinking about this here, I'm going to go tangent of 43 degrees is equal to opposite over adjacent, which is 11 plus 6. Okay, good there. So I'm thinking to myself, you know, that's cool. How about if I do this one as well? How about if I do tangent of 57 degrees would be H over X. That's kind of cool. Cool. What a nifty little trick, huh? You just equate something you don't know, but as long as you know that you don't know is the same in both parts, you do that. Okay, so let's do this here. Let's solve both of them for h. So I'm gonna, on the left-hand side, I'm gonna multiply both sides by 11 plus x. On this one, I'm just gonna multiply by x. Tangent of 57 is equal to h. Perfecto. Love it. Okay, h is equal to that, h is equal to that. Therefore, I know that these pieces are equal to each other. All right, then comes the solving aspect here. So I think I have to distribute. You guys think it's a little crazy here? You know, in algebra, you just had an x only, and that's about it. Now you have tangent, you have words inside. Inside math here, they actually mean something. All right, talk to me, anybody. What do we do? Gotcha. Okay, I think is that what you were saying?
Yeah.
Okay. We need to get x's. We need to get all x's together on one side, because that's the way we did algebra. You remember a long, long time ago, in almost the same place. If you learn algebra in Sloka, yeah, the x has to be on one side, so you have to move it over. And I keep on putting 47, huh? It's actually 43, right? So can I go back? Of course, no one's telling me that. They're just.
You, right?
I didn't know if it was still 43 and your
Yeah.
handwriting was just a little bit off.
Yeah.
It's that bad, huh? Math teacher. Okay, so that's gone. And I am left with 11 tangent of 43 degrees, and I have x tangent 57 degrees plus, or so minus x tangent 43 degrees. I'm going to squeeze it in there. We're good? So I'm running out of space here. This is a tough one. Probably one of the, if I'm looking at the homework correctly, one of maybe 3 or 4 tough ones here. Okay, I have 2 x's. I'm trying to solve for x, so I'm going to factor. This is all these factoring techniques that we learned in algebra here. I'm going to take out the x here. Tangent of 57 degrees minus tangent of 43 degrees. And I'm going to divide by that right there. So finally here, x equals, totally running out of space here, 11 tangent 43 degrees on top. And see how you punch this into your calculator here. Tangent of 57 degrees minus tangent of 43 degrees.
It's 16.8, which you rounded to 17.
Cool, okay, 16.8 or 17? Cool, you're good? Second on that, okay. And who asked that question? Are we good now?
Yes.
Awesome. All right, keep on jamming. 53 and 61. So I'm going to write off to the side here. Still got to put this guy in the bottom. Three. 53. The soccer field. All right. Yes. Remember the soccer field. And C to D. This is 12 feet. That's cool. Soccer ball is right here. And another right triangle appears. That's so fun. 54. That's 54. So a penalty kick is taken from a corner at position A. The goalkeeper stands in the center of the goal and can thus block the shot anywhere in segment CD. So he has a what? 12-inch arm span or 12-foot arm span. To score, the shooter must kick the ball within the angle CAD. Oh, CAE. This is A, this is E. So it's this little piece right here. Or DAF. So it's this little piece right here. Anybody finished off the problem? Anybody done? Anybody finished off 53? Cool. Okay. Got a couple of people here that did it. Okay. Find the sum of the two angles to the nearest tenth. So I need to add up this one and add up that one. Okay. Any helping out? What should we do?
About when you take the tangent of DAF.
DAF, tangent?
BAF.
B. EAF, this guy here, the big one?
Yeah.
Okay,
It's
Tangent,
54 over 54, which is 1.
tangent of, I'm gonna go, so EAF, is equal to?
Wait,
You
Can
guys talking?
you do that because it's not a right triangle?
I think so, yeah. We haven't got to non-right triangles yet. We'll get there.
No, I was saying BAF.
BAF. Where is B? Oh, gotcha. Thank you. BAF. Okay, that's cool. Okay, yes,
And then you do inverse tangent.
Okay, you're gonna get this degree here, right?
Mm-hmm.
That's cool. Okay, Grace, keep on talking here. How did you, so I got this angle. I know what that would be.
Mm-hmm.
Next, how would I figure out the rest?
So then after you do the tangent of BAF, you do the tangent of BAB. And to do that, you have to add 6 feet to the 54 because there's that 60-foot space up there. It's going to be 60 over 54.
I am not sure if there's 6 extra feet there.
Because it says that the length of the whole goal is 24 feet, I think, and then it says that the length in between both of the two angles is 12, and so each of those side ones should be 6, right?
Yep, awesome. Yeah. Let's see, up on top, before 52. So thank you, or else I would have been doing this for quite a while. That is 6 feet here, and that is 6 feet there. Makes 24 all the way across, right? And I had to subtract a little bit here.
Mm-hmm.
Perfecto. So add that one. So we have tangent of BAD, and that's going to be opposite, which is now 60 over 54.
Mm-hmm.
This was 54 over 54, and that should have been actually 45 degrees. Everybody agree there?
45 degrees, and then this one is 48 degrees.
Awesome,
Wait, where
yeah.
did we get the 60 from?
Because it's 54 up top from F.
Oh,
to
I
B,
see.
and
Oh, I
that's
see.
60.
That's cool. Okay. And that turned out to be 48 degrees?
Yeah, 48.
Cool. Okay, whoever had 53 as the question on their homework here, are we okay? Are we tracking? Is this making sense? So we're kind of filling out this angle here. So if you need to do this on your calculator, 54, do tangent inverse, you get 54. Or you should realize that this is always going to be true. Tangent of 45 degrees is 1. And so this guy, if you're trying to find the angle of something, if it's 54, you're going to get 1. Cool. Good job, Grace. Good job in that. Okay, 48 degrees is here, so this guy has to be 3. So I found angle want to name it correctly the way the book does. DAF. There you go. DAF is 3 degrees. Right. Now the question is, how do we go further? DAF, that little,
Oh, yes.
yeah, that little one right there, 3. Okay, did you keep on going then? Added the 12 then?
Yeah, so then, yeah, for BAC ends up being 53.1.
Let me just write it in here. So it's going to be 54 plus the 6 plus the 12 now. So I got 72 over 54, getting a tangent inverse of 72 over 54.
Wait, wouldn't BAD be 3 degrees? Not. Or
Sorry.
ADF?
It's going to be either FAD or
I mean,
D.
FAD.
Yeah, FAD or
Oh.
DAF. It's going to be the same thing. All right. DAF and FAD. Okay, how about this one here? Anybody give me 72 over 54 tangent inverse? Thank you. 53.1 degrees. And we are getting there. Subtracting 48. We really don't need that one, right? So we just know that this whole piece is going to be 53.1 degrees. That's cool. And the last one here, tangent of BAE is going to be equal to
78.
take tangent inverse of that. Angle BAE, 78 or 54, and what did you get?
55.33.
All right, 55.3 degrees. Awesome. So then it's a subtraction between this one and this one, right? 55 minus 3, and that would be? Let's write down the
Wait, so
angle.
this for CAE.
CAE,
That would be 2.2.
Sounds about right,
BAE minus BAC.
Mm-hmm. That is cool. Good job. That is real cool. All right. Anybody that had a question on it? Are we good now?
Well, and then for the last step, you have to add the two together, right?
Find the sum of the two angles. Okay. 5.2. 5.2 final answer. Degrees. That's right. I didn't have that. Okay. Cool. Are we good there? Sweet. Okay. Looking at time as we got to go on. 2.3, number 61. We got the Ferris wheel problem. Okay, there's an A, B, and C part to it here. So a Ferris wheel, Mr. Ferris invented the Ferris wheel.
Did they invent the Ferris wheel like
They created the wheel thousands of years ago.
We're just like going around.
they only had squares?
Aristotle, yay, this is so cool.
The only way they could entertain themselves. The first grade for me ever called was named the Ferris.
You have to have like 6 guys with a big log.
Oh my God, you're looking at bow tie. Yeah.
Okay, let's go with it. This guy looks like P initial. This is P1. And then there's a height that comes along. And we got an angle that starts from the initial position this way. So find H, find the height. This is the height here of theta if the angle measurement is 120 degrees. So 120 degrees, first of all, that's not down here. That's actually up there, right? That's more like up here. Here's your 120 degrees. In calculus class, what we did is I took introduction to engineering here. What the prof had us do is the Ferris wheel going around a certain rate, right? And we have us over here, and we have the person we don't like sitting on the Ferris wheel, and we chuck a rock, and we got he's a little violent professor, but yeah, we had to figure out the trajectory of the rock in order to hit him just right.
Useful.
Okay, see, Matthias has got interested in trigonometry.
You've got me.
Real life application. Substitute them all.
So are you gonna throw the rock at, like, figure out the trajectory and then know how to throw the rock at that trajectory? Because it's not just something you program into yourself.
Yeah,
You have to be able to do it.
Right.
I can do
Andy,
it.
not you. I got a full extra.
That's right. It was physics. That's right. Introductory physics. I
Just
remember
follow
that.
your robot arm, like your robot.
Wait, also,
Are we implying that the rock travels in a straight line?
The what?
Are we implying that the rock travels in a straight line?
No. Implying that it has to curve. So we had to build in the force of gravity upon the
I
rock.
was gonna say, if you somehow accelerate the rock to going a significant fraction of the speed of light, and it probably appear to go in a straight line. So, you can just do
the
that.
problem about living.
Yeah, that doesn't sound like a problem.
The problem about being faster than
Yeah,
the
I
speed
don't
of
see how
light
this
is
is real
that.
life.
Okay, let's go with it.
Just bring your partner.
Diameter of the figure is,
You set it up for like a mile before the third.
and I forgot here. Is it somewhere? It's not Santa Cruz. It's somewhere on here in California. There's a Santa Monica is the. It's not the original Ferris wheel, is it? Or is it?
Yeah.
I think it's the original Ferris wheel.
I don't, Santa Cruz. Ferris Wheel.
Yeah, but
I don't know if one of the originals. No.
yeah, or one of the originals. So it's here in California somewhere, because I know I have a picture of me on it with family. It's inside a shopping mall or just outside a shopping mall or something like that. There's just this
Probably.
old
It's on
Ferris wheel. It
here.
doesn't work
Yeah,
anymore.
they're on a pier.
Yes, yeah, it's on a pier.
Probably
Probably
some
Santa
on
Monica.
Okay, and so yeah, and then it has a little thing with it. Mr. Ferris wheel invented this, and I don't know if is it the original or just a model original?
that. And Mr. Ferris wheel.
Mr. Ferris with a wheel.
He's like, I feel like I should make a wheel and then name it after myself.
Okay.
Mr. Ferris wheel.
Let's check it out. So the diameter of this thing is 197 feet. That's good. The top of it stands at 209. So that kind of gives you a little bit above the ground. And so move the initial position. Okay, I think we got what we need to hear out of it. So that's 209 and that's 197. I guess I have this little extra piece right here, don't I? By just subtraction, which is how many feet above the ground? I don't think we'll make it through all these homeworks. 209 minus 197. Anybody with that one?
98, I think.
209 minus 97.
Oh, wait, obviously. not.
312. I think it's 12.
12. No, wait,
12.
12 is fine. It's 8.
No, 12. Yeah, it's 12.
Wait, 209.
9 plus 3.
Oh, it's like a 5.
Sorry,
Yeah.
chicken scratch here. So 12 feet above the ground. That's cool. Next is, how do we compute this? Anybody? 61.
I found the radius, yeah, by dividing the diameter.
Yeah, half of 197, which is 98.5. Yeah, 98.5. That's cool. Next. Oh, I think I can I zoom in on these? No, I can't.
I thought I got 110.
Okay.
Are you
It just magically appeared to you. Like how you do it? I think it's.
Oh,
My favorite method.
Thinking maybe this. How about this? How about if we just cut this little line right here? Just make a big old line right here. Because I think we know the height up to here, don't we? It's going to be 12 plus the radius itself. So anybody 12 plus 98.5.
Oh yeah, that's right on.
yeah, that's what I was gonna say.
Yeah.
Okay.
Too, which I was like,
Is it 110.5?
Yes.
Okay, 110.5 is to the middle of the Ferris wheel from here. And I'm not sure if this is the only way to do it, but at least one way. So if we have gone 30 degrees past 90, right? Because we had to go through 90 and then we went to 120, so we had 30 degrees more. Okay, then the only question is what's that right here? And I think I formed my right triangle. 30 degrees, 98.5 feet, and I need to know that right there. Which trig function?
Wait, no.
I did
Sine. Yeah. I mean, I did the.
Okay, gotcha. I'm going to just go with sine. That okay? And you may have done it a different way as well. So sine of 30 degrees is equal to x over 98.5. Nice one. I like this one better because it's just one multiplication on this side. Anybody 98.5 times sine of 30 degrees?
sine of 120 degrees.
Yeah, I did too.
I don't know why I did.
But I got it right.
Yeah.
That is so cool. All right, let's explore.
What did I do?
I did 110.5 minus 98.5 cosine 120.
Wow. Okay, let me finish up my way and then we'll go from there. Anybody punch in 98.5 times sine of 30? 25, so 49.3, not degrees, it's values. Okay, so we're gonna punch in this, Amaya. Punch in sine of 30. And then real quick here afterwards, punch in sine of 120.
I got the 1.5, the other 0.866.
Okay, so it's different here. For some reason, I thought that might be the same. No. Okay. I'm gonna go with this one here. Is that okay? This is my height to here, 49.3, and I'm gonna add it to 110.5, and I should get my answer. Are we good there? Should we explore all the other different ways? Let me just check.
Yeah,
Let me go
so
back over here.
if that gets 160, which is what I got at the end. So,
Okay. Should we explore how you guys did it? You guys want to know why it worked out or no?
Oh, wait, no, I'm wondering. Oh, I think what I might have done was when I originally, yeah, because cosine of 120 is negative 0.5 and sine of 30 is 0.5. And then when we did cosine of 120, I bet we ended up coming out with the same answer. So that might
what my goal is watching people done it.
Wait, I missed you. What car? I missed you. Right on top of the
Oh no, oh no.
That's funny. Okay, question is this. We have not made it through the homework assignment. We have not finished up. I do want to finish up so you guys are at least more confident to the test here. I'm going to do this here. I'm going to go with finish up the rest of the homework on Friday. And then test on Monday. Gives you a little weekend to study. After you do line dancing and stuff like that, you guys would clear your head in order to take a test.
Oh, yeah. I don't know. Yes.
Yours is the easiest. It's so easy.
So I don't need to learn it yet.
Okay, then it's really hard. You need to learn it.
Oh yeah, we need to practice and reference here.
Yeah, no, I need to learn, yeah.
I have not even watched the video,
Oh
so.
my gosh,
What video?
man.
I have to learn my dance. My dance. Cool.
Oh, yeah. Why didn't you just learn the video